Alright, salam and good day. My name is Razlan Shakil and I'm from 6BME2. In this video, I will be talking about the impact of 5G towards the aviation industry. Right, so to begin, what is 5G and how does it affect the aviation industry? So the 5G is basically the fifth generation network which is used in your phones, so like mobile networks such as 1G, 2G, 3G, 4G. So currently the most latest one is the 4G, and the latest one right now, the one that we're talking about, so right after the 4G is 5G. So it's a new wireless standard, right? So with the 5G wireless technology, more users will have access to faster peak data rates in gigabytes. It's really fast. It's in gigabytes, and it's extremely low latency, which is great for gaming. For increase or Teams call, anything that requires stable network connection. Is a huge capacity, and increased availability, and basically a more consistent user experience. Right, but this sounds great and all to the Republic, but it's not for the aviation industry. But why is that, right? Okay, so in the US right now, so existing 4G stations are being re-equipped to operate 5G signals, and these 5G signals, how it works is it's being sent directly towards the receivers instead of having a typical general network coverage. Okay, so signals will be sent directly to the user that is nearby to the tower. And okay, so but the problem here is that the higher frequency range of this 5G band is about 3.98 gigahertz, which is only 0.22 gigahertz from the band used in radio altimeters by aircrafts, right? So radio altimeters in aircrafts using band from 4.2 to 4.4 gigahertz. Right, so you have this small separation of 0.22 gigahertz, right? So how would this affect aircraft, these radio altimeters, and if if radio altimeters are affected by this 5G signal, how would it affect the safety of the aircraft, right? Okay, so let's talk about the radio altimeter. So it's basically a device that measures the height between the aircraft and the terrain below. So this device, it transmits radio signals from the belly of the aircraft towards the ground, and it bounces back to the aircraft. So with this, it judges and it calculates the altitude of the aircraft, and it is used in the landing phase by the auto land. Right. So due to this low separation band, so there's a potential where the higher frequency range of the 5G interrupts the radio altimeter's frequency. So what this could do is it could cause a miscalculation of altitude by the radio altimeter, leading to a runway overshoot. So like I said just now, so basically how the altimeter works, and it sends back down and sends the signal down and back up to the aircraft. But if there is a 5G tower nearby and there's a user right here, you could send that signal and interrupt that signal being sent by the radio altimeter. So this can cause a miscalculation, just a jumble of numbers, not getting the correct numbers. So what this can cause is, for example, an aircraft has touched the ground, but the autopilot still thinks it's a few thousands of feet in the air. So this does not allow the aircraft to turn on its activate its braking systems, such as the spoilers and the reverse thrusters. So you're on the ground, you can't activate your braking system, so this leads to a runway overshoot. Another example, and this is very, very detrimental in a low visibility situation where there's fog, heavy rain. So the pilot heavily relies on the aircraft instrument system. Another example is that aircraft thinking that is a few sorry. Another example of this aircraft is thinking that it entered the landing phase, but in reality it's a few thousand feet in the air. So then the aircraft would start to flare at a certain altitude. So this is to land, you flare and then you land smoothly. But since aircraft still thinks it thinks it's on the ground, but it's still a few thousand feet in the air, the aircraft would just flare in inappropriate altitude, and it could reduce the thrust levels because it's thinking it's on the ground and wants to brake. Okay, so this can cause logically catastrophic incident, right? So right now, to put that into perspective of how it affects the aircrafts, we're talking about the Boeing 737 aircraft alone, right? So it affects 2,442 airplanes in the United States and 8,342 worldwide. So you can see this is a really big problem. So, but now with this 5G rolling out, it doesn't seem like it's the next future step in the future. So, how do we overcome this problem? Okay. So based on the FAA statement on 5G on 17th of June 2022, by the end of 2022, operators of regional aircrafts with radio or altimeters that are particularly susceptible to this interference must upgrade the aircraft with radio frequency filters to prevent the 5G signals of interfering the radio altimeters. Right. So right now we have companies such as Embraer, Boeing, Airbus, and they're all working with their radio altimeters manufacturers to create and install these filter kits. Right. So right now, as we speak, the kits are being sent to the customers, airlines, and basically any operators of these aircraft. So at facilities such as airlines maintenance, these kits may be typically installed in a short amount of time onto the aircraft. So they just need to create that, send it to the customers, and the customers can install it on the aircraft. At the same time, the FAA are collaborating with their wireless providers and to pinpoint location where 5G affect the aircraft. So they're trying to reduce the chance of it interfering the radio altimeters and to relax mitigations around key airports in carefully considered phases. Right, and that's all from me. Thank you.